Scholar under the guidance of Dr. Edson John from MA College of Engineering, Kodamangalam. I am doing my research under the APJ Abdul Kalam Technological University. As we know, the sustainability is the key to a better future. And the construction industry is one of the main source of environmental impact issues. Then as a civil engineer, I am going to discuss with you how to achieve an environmental impact, how to achieve a sustainable environment from the construction engineering side. The primary goal of the sustainable construction method is to reduce the environmental impact by minimizing the energy consumption. Then, how can we minimizing the energy consumption in construction industry? And today I am going to discuss on how we can improve the sustainability by using the high performance concrete. These are the things I am going to discuss today. And as an introduction, coming to the definition, according to ECA concrete terminology, the HPC is a concrete meeting the special combinations of performance and the uniformity requirements that cannot be achieved from the normal conventional concrete. It is having the exceptional performance of strength and durability. The strength means the compressive strength of high performance concrete holds more than 60 MPa. Thus, it can be used in the construction of bridges, hydropower structures, pavements, mass concrete structures, etc. It is composed of an optimized gradation of granular constituents. As all of you know, the concrete is made up of the aggregates, cement, water, plasticizer, chemical and mineral admixtures and all. If we are optimizing the gradation of these constituents, then we will get a complete particle packing density. Thus, we can improve the strength of the concrete. Then we are considering the water to binder ratio less than 0.3 and we are incorporating high percentage of fiber reinforcement. Then as I said, we are using the low water binder ratio. We are considering the optimized particle packing density and we are using high pozzolanic content. Thus, we will get a dense microstructure and thus we can improve the strength of the performance concrete. Then as part of the sustainability, the cement production is the third highest source of carbon dioxide emissions behind the automobiles and the coal plants. By using the high performance concrete, we can reduce the environmental impact of cement production in the construction that we will discuss later. If we compare the normal concrete, high performance concrete and ultra high performance concrete, when we compare the compressive strength, the normal concrete is less than 50 MPa. When you consider the high performance concrete, it is greater than 60 MPa. If you come into the ultra high performance concrete, it is greater than 150 MPa. Similarly, all other properties that will be more when you compare the normal conventional concrete. When we design the high performance concrete, we have to consider the superior mix design. The superior mix design means we have to optimize all the constituents in order to get a very good packing density. Then in order to get the higher compressive strength, we have to use high cement content and have to use the low water content. Then in order to get the flowability, we have to consider the superplasticizer. And in order to increase the ductility and other tensile properties, we are incorporating the fiber and have to give the better curing. Better curing means in this case, in order to produce the high performance concrete, we are using heat curing. By providing the heat curing, we can enhance the microstructure. Then we have to optimize the granular mixture. By optimizing the granular mixture, we will get the compacted density. Then in this case, we are not using the fine aggregate, we are not using the coarse aggregate, we are using only the fine aggregate in order to increase the packing. Thus, we will get better homogeneous mixture, and by incorporating steel fibers, we can increase the ductility property. And coming to the sustainability aspect of HPC, if you are considering the high performance concrete, when you compare with the normal concrete, we can reduce the amount of concrete by using the high performance concrete. By reducing the amount of concrete, that means we can reduce the cross section of the structure. Thus, we can improve the aesthetic appearance. Then as I said, in order to produce the high performance concrete, we need high cement content. That high amount of cement content can be substituted by using supplementary cementitious materials like GGBS, Alcofine, etc. Thus, we can reduce the carbon dioxide emission while producing the cement during the cement manufacturing. Then, while we optimize the high performance concrete, we can lower the energy consumption and emissions. Thus, we will get green and clean concrete product. By usage of reduced cross-section structures, we can reduce the environmental impact issues as well as the maintenance cost. Then this is what I said earlier. When we use the conventional concrete and high performance concrete, in order to sustain a load P, we need that much height in the case of conventional concrete, and we can reduce the height by using the high performance concrete. That is because of the optimized practical parking density, as we see in the second figure. By using the HPC, we will get a better particle packing than the conventional concrete. We can see that in the conventional concrete, so much of walls and so much of gap. And by particle packing density, what is particle packing density? That means you have to get the more dense structure. That is called particle packing density. That will be obtained by the lower the water to cement ratio and by using the fine materials more. The materials used for the ultra high performance concrete or high performance concrete, that is the ordinary Portland cement, alcofine, the granulator blast furnace slag, then manufactured sand, steel fiber, super plasticizer and water. Then as part of my investigation, we were varying the different constituents in order to optimize the mixture and in order to get the better strength of maximum 100 MPa. In order to get that mixed proportion, we were varying all the constituents by different proportions. Here we are considering the cement content by keeping the total binder content as constant, water binder ratio as constant, fiber content as constant. We were varying only the cement content as 500, 600, 700 and 800. Then we have drawn a particle packing density curve by using MR software. We were inputting all the particles as gradation of the aggregates, gradation of the cement particle, gradation of alcofine and all. Then we will get a particle packing density like this. The blue line represents the modified Andreessen model, that is based on MR software. MR software is based on modified Andreessen model. That's the blue curve representing the optimum curve. If we varying the cement content as cement C500, 600, 700 and 800, we will get the graph like this. From this figure we can understand that all the graphs that will be on almost same. The compressive strength also we got, if we are varying the cement content to 800 kilogram per meter cube, we got almost the same compressive strength. There is no much increase in the strength. That means beyond 600, if you are increasing the cement content, that cement content does not impart any strength, that will act as the filler only. The next we have varied the binder content. Binder content means the binder means cement, GGBS and alcofine amount is the binder content. The total amount of cement, GGBS, alcofine we were varied from 1000 to 1600. This is the MR graph. The green line represents the optimum curve. As we increase, the R 1600 is the blue line and the yellow line represents the 1400. As we increase the binder content, that means the final particle will be more. If we increase the final particle beyond a particular limit, that may lead to the separation of the mixer. When we are considering the fiber compressive strength, beyond 1200 there is not much increase in the strength. That means we are considering 1200 as the optimum. Then while you are using the high performance concrete, we can reduce the cross section. We will get the good strength. We can reduce the maintenance, chemical resistant, impact resistant. We can lower the carbon footprint. Then ductility, you will get the good adhesiveness, and the durability is good, and we can save the maintenance cost. And we can apply this high performance concrete in the highway infrastructure, bridge deck, seismic column, accelerated bridge construction, bridge girder, wind turbines, tunnels, etc. As part of the conclusion, the curve obtained from the MR software give a clear idea about the particle distribution of all the particles to get the optimum mix. And the amount of cement content can be limited to 600 kg meter cube. If we increase the cement content more, that will act as the only fillers. The quantity of total binder content can be limited to 1200 kg per meter cube in order to achieve the compressive strength of 100 MPa. These are my references. And I would like to take this opportunity to thank all the organizing committees of the STAM23 to give me the opportunity. And also I acknowledge the management, MACE, to provide the facility, and the Kerala Highway Research Institute for funding my project. This is a funded project and it's a combined project with the association of IIT Madras, IIT Tirupati and NIT Calicut. Okay, thank you.
Any questions, comments?
So apart from the cement content and also binder content, what are the other parameters we can choose for the best performance of this?
Actually, in my investigation, it is continuing with the different fiber content, with the different types of aggregates, the different water binder ratio. The research is actually going on. We got the optimum fiber content and optimum water binder ratio, and with that mix, with all the optimum, we have casted some specimens. Actually, we got only the 7-day strength only.
Okay.
That 7 strength is almost 100 MPa.
Okay.
I understand this high performance concrete, it has many good things, but what about the cost? Because we may need some energy to disrupt into make it into small particles, right?
Yes.
So what about the cost?
Actually, sir, at the time of production, the cost is very high, but during the maintenance, that will be less.
Okay.
The time of construction, that means we need the large amount of mixer, high RPM mixer, and we have to keep the heat curing and all. The production cost will be more.
Any other question? If not, thank you very much for this nice presentation.
Okay, thank you, sir. Thank you all.
The next presentation is by Anisha Joseph from MA College, and the topic of the presentation is an investigation of the structural and optical properties of NB-doped SNO2 thin films.
Very good evening to one and all. I am Anisha Joseph, a part-time research scholar in the Department of Physics of Marathanesians College, Kodamangala, under the guidance of Dr. Deepa S. Here to present the paper titled An Investigation of Structural and Optical Properties of Niobium-Doped Tin Oxide Thin Films. The contents of my presentation are introduction, research objectives, experimental details, results and analysis, conclusion, and references. Introduction. Among the different types of metal oxides, tin oxide is the most widely used one due to its high surface activity, electrical sensitivity, and wide band gap. Research studies prove that the deposition conditions have a crucial effect on the characteristic properties of metal oxide thin films. For the present work, I have selected niobium as the dopant due to its excellent catalytic activity. The main objectives of this work are to prepare pristine and niobium-doped tin oxide thin films under different weight percentage by chemical spray pyrolysis method, and to investigate how the dopant concentration will affect the structural and morphological properties of the material, and to study how the dopant concentration will influence the optical properties of the prepared samples by using different characterization methods. The experimental details: a mixture of tin chloride with 20 ml of isopropyl alcohol is dissolved in 20 ml of distilled water, and to this precursor adequate amount of niobium pentachloride is added, and the solution is stirred well and it is dissolved. The dissolved solution is sprayed on a preheated silica glass substrate at 345 degrees Celsius. Then uniform thin films of consistent structures are formed. Results and analysis. Here, the structural and morphological characterization is done by using X-ray diffractometer and field emission scanning electron microscopy, whereas optical characterization is done by using photoluminescence, UV visible and Raman spectroscopic analysis. The first one is X-ray analysis. The figure shows the X-ray diffraction pattern of pristine and niobium doped tin oxide thin films at different weight percentage, say 1, 2, 3 and 6 weight percentage. And XRD pattern shows a high intensity diffraction peaks at specified black angles, and it indicates that they are cassette structures. The peak positions also exactly matches with that of the standard JCPDS data. Then from the graph it is clear that the intensity of the prominent peaks decreases with the higher weight percentage, and it may be due to the recrystallization that may happen at higher weight percentage. These are the crystalline sizes, lattice parameters and lattice strain and dislocation density. They are calculated from the X-ray diffraction data, and from this it is clear that the 6 weight percentage niobium doped tin oxide has the least crystalline size of the order of 24 nanometer. The same thing is plotted here, the crystalline size versus the weight percentage niobium at a different weight percentage of niobium graph. Here also it is clear that 6 weight percentage has the least size. And the texture coefficient at preferred orientations are calculated by using the equation Tc is equal to I by I0 divided by 1 by n into summation over I by I0. And it is observed that these niobium doped samples shows a preferred orientations along 110 and 200 planes, whereas the 101 and 211 planes have Tc values more or less same. These are the FESM pictures of the prepared samples, and from this also confirms the grain size reduction in the case of 6 weight percentage niobium doped samples. And also it is clear that the morphology is different for different weight percentage. Now we are moving to the optical characterization. Here the first one is UV visible spectroscopy. From this UV visible spectroscopy, the energy gap EG is calculated from the top plot, and it is observed that for the pristine sample EG value is 3.78 electron volt, whereas for the moderately doped niobium tin oxide thin films it is around 3.54 electron volt. And again the absorbance curve shows that the moderately doped samples have higher absorbance, and if again we are increasing the weight percentage, that approaches to that of the pristine sample. These are the photoluminescence curves of the pristine and the doped tin oxide thin films, and it is seen that for the moderately doped niobium doped tin oxide thin films, they have shown a higher intensity, and it indicates the presence of oxygen defects within the sample. As again, if you are increasing the weight percentage, there is a decrease in intensity that may be due to the absence of the defect centers within the sample at higher concentration. And to get a better insight, these plots are deconvoluted into different Gaussian peaks. Here it is shown here. These are the Raman spectroscopy results of the pristine and the doped niobium doped tin oxide samples, and it is seen that at 813, 624 and 464 centimeter inverse, the Raman active modes that corresponds to B2G, A1G and EG are observed. And here also it is seen that as we increase the dopant concentration, it exhibits a blue shift in the Raman spectra. In order to get a clear picture, the curves are deconvoluted, and this also indicates the presence of oxygen defects and oxygen vacancies. Let me conclude. So in the present work, the pristine as well as the niobium doped tin oxide thin films at different weight percentage, say 1, 2, 3 and 6, are formed by using chemical spray pyrolysis technique. Then the XRD analysis have confirmed the polycrystalline nature of the formed samples, FSM analysis confirmed the grain size reduction in the 6 weight percentage of niobium doped sample. Then from the optical studies, UV visible spectroscopy, the narrowing of band gap is confirmed from the top plot, and it is seen that the band gap energy decreases from 3.78 electron volt to 3.54 electron volt. Then PL and Raman analysis have proved the presence of oxygen vacancies and defect sites and surface defects. All these points towards that these niobium doped samples are better candidates for gas sensing applications. These are my references. Let me take this opportunity to express a sincere thanks to Dr. Deepa S., my research guide, and the principal of Marathanesius College, Kodamangalam, for providing the research facility, and also KTU RSM for funding this project. Thank you.
Thank you. Questions? Any questions?
It's nice to see this change in shape in the SEM. What do you think the reason for it?
Sir, earlier research works in our lab itself, it indicates that if there is a size reduction in the samples, that shows a better sensitivity, that samples are good for sensing applications. In our own previous works also the same thing. So for this, in this case, there is a very different morphological structure we have observed in 6 weight percentage of niobium doped samples. It might be there is a better chance to act as a good sensor.
Yes.
For sensor applications. That is the conclusion. And that depends on the dopant concentration and the ambient, how we are forming this sample, the temperature, substrate temperature, everything can affect this morphological structure. This particular sample, that one is formed at 345 degrees Celsius. The same parameters I have taken, and if I am doing it at 250 degrees Celsius, this morphology will be different and it may not show this much of good results.
So did you use your samples for any gas sensing applications? You prepared the samples and further did you study?
Sir, this particular set of samples I didn't use it so far, but in the initially I have prepared a manganese doped tin oxide thin films, and that shows good sensing towards methane as well as LPG sensing. This set I need to do it.
Okay.
Coming days.
Okay. Okay, thank you, Anisha Joseph.
Thank you, sir. Thank you all.
Our next speaker is Anand Shajan, and he will be talking on photocatalytic water treatment using zinc oxide thin films in the presence of sunlight. Okay, so he is absent. So moving on to the next speaker, Anjali Sidwan, and she will be presenting tailoring the structural, magnetic and dielectric properties of cobalt ferrites by chromium substitution.
Good evening, everyone. Myself, Anjali Silvan, MSc student, Environmental Physics, Marathanesius College, Kodamangalam. I'm here to present the project titled Tailoring the Structural, Magnetic and Dielectric Properties of Cobalt Ferrites by Chromium Substitution. Here is an overview of the presentation. Introduction. Nanomaterials exhibit enhanced properties compared to their bulk materials. The desirable structural, electrical, magnetic and dielectric properties make the ferrites a great focus area. The ferrites have become increasingly important materials for electronics and biomedical engineering applications. Then, among such a huge varieties chromium nitrate hexahydrate and ferric nitrate monohydrate are the raw materials used. The raw materials are mixed thoroughly in ethylene glycol and sonicated in room temperature for about 20 minutes. This homogeneous solution is vaporized at 150 degrees Celsius till a dry jelly is formed. The obtained jelly is ground and is centered for 2 hours at 800 degrees Celsius. Characterization. Structural characterizations were done using XRDs and morphological and composition analysis were carried out by FESM. Magnetic characterizations were carried out using quantum designs MS and dielectric studies were also done. Then results. Structural characterization using X-ray diffraction. The XRD patterns were of the synthesized materials was done for 2 theta range 20 to 80 with an increment of 0.02 degrees Celsius, and the average particle size of the synthesized materials were found out using the Schroeder equation, and the average particle size of the synthesized materials were found to be in the range of 43 to 50 nanometer. The XRD patterns obtained was compared with the ICDD data, and it confirmed the presence of the synthesized material, and all the peaks index to the spinel structure, and the particle size of the various chromium doping concentrations given in the table 1. Then morphological and compositional analysis using FESM. The physical, texture and morphology of the synthesized materials were studied using FESM. The images are shown here. These are the FESM images of the synthesized materials of different chromium doping concentrations. And from the figure, we could understand that the crystal grains are clearly visible in all of the samples, and the grain, and if you look in, we can see that the grains are inhomogeneous in size. And here is the area spectra of the labs. From this, we will get the elemental weight compositions. In the table 2, I have given 2 values, and the bracketed one is the theoretical, and the other value is what we obtained from the EDA spectra, this one. Now coming to the dielectric study. Dielectric properties such as dielectric constant, dielectric loss and AC conductivity of the synthesized materials were studied as a function of frequencies ranging from 100 Hz to 4 MHz at room temperatures, and the values dielectric constant, dielectric loss and AC conductivity were calculated manually using this equation.
questions?
So what are the doping concentrations you used for this?
For chromium it's 0.25, 0.5, then 0.75, and here for magnetic studies I used 0.5, then fully doped and pure samples. And these every concentrations that I have synthesized.
And which concentration you found better properties? Means any optimum value?
Pure has the maximum values. That is non-doped materials has high values.
High values.
On increasing the doping concentration, the values decreases.
So what are the applications of your prepared samples? Any?
I have not done.
No. Even if you haven't done any applications, means we all do for some type of applications.
Yeah, ferrets, electrical applications like lithium batteries.
Okay. Okay. Thank you. So the next presentation is by Ashna and Kuriakos from MA College, and the title of the presentation is Electron Paramagnetic Resonance Spectroscopic Method for the Detection of Honey Adulteration with Sugar Syrup.
Wishing a pleasant evening to all. I am Ashna Kuriakos here along with Ms. Abhina Susan Paul and Dr. Sarda K. Nair, Department of Physics, Marathanesius College, Kodamangala. Here, I am here to present on the topic Electroparamagnetic Resonance Spectroscopic Method for the Detection of Honey Adulteration with Sugar Syrup. Food adulteration is one of the most common practices nowadays. Food adulteration is a process in which an external chemical substance is being added to the food product, which is similar to that of the natural substance. The most common food adulteration is seen in honey. In honey, cane sugar or corn sugar is being added as the adulterant. There are various methods for the detection of adulteration in honey. They are the chromatographic method, the microscopic analysis method, the IRMS method. The limitation of the chromatographic method is that most of the major sugars are having similar profile. The limitation of microscopic analysis is that in industrial microanalysis, The vegetable key markers such as the sclerous cells and epidermis cells are being removed. Next one is the IRMS, that is the isotope ratio mass spectroscopy. It can be used for the detection of C4 plant sugars which is used as adulterant in honey. However, we have not used these methods, we have used the electron paramagnetic resonance method in order to determine the adulteration in honey. The electron paramagnetic resonance is a branch of spectroscopy in which electromagnetic radiation, usually microwave frequency, is absorbed by the molecule, ion or atom possessing electron with unpaired spins. Here the sample is placed on a strong static magnetic field in which an orthogonal low amplitude high frequency wave is interacted. The unique feature of the EPR spectroscopy is that it can be used for paramagnetic substances as well as substances that can be excited to a paramagnetic nature. Here we have made in EPR spectroscopy, we make use of a stable nitroxide radical that is called a tempo, that has a probe. The first method for the experiment is the sample preparation. For the sample preparation, we have taken locally available honey that is marked A grading for the experiment. The sample sugar syrup is prepared from locally available brand of cane sugar. The sugar syrup is prepared by dissolving cane sugar in water till saturation, followed by boiling to get a clear syrup without precipitation of the crystal. Now to the honey, this sugar syrup is added as 10, 20, 40 and 60 percentages by volume, and to this sample we have further added stable nitroxide radical as tempo in order to get an easily analyzable 3-line spectrum. Now we have come to the EPI experiment. For the EPI experiment, we have made use of the Bruker EPR spectrometer. The tempo added sample is taken in a capillary tube and it is then placed on a glass tube with one of its ends closed. This glass tube is then introduced into the resonant cavity of the EPR spectrometer where the microwave interacts with it. From the EPR spectrum, we can observe various parameters such as correlation time, extrema max separation, central line width, first line width and third line width. The graph to the left is the EPR spectrum that is of the unadulterated honey, and that to the right is the EPR spectrum of honey that is adulterated with 10% of sugar syrup. Various parameters had been obtained from the EPR spectrum. From these graphs, we can see that the graph for correlation time shows a gradual decrease, whereas that for first line width, second line, third line width and many other parameters does not show a gradual decrease. The gradual decrease in the correlation time with the increase in the percentage of sugar syrup added can thus be used as a method for detecting adulteration in honey. As a part of the conclusion, I would like to say that the use of suitable paramagnetic probe and the addition of it into the sample syrup can be used as a method for the detection of adulteration in honey. These are the references that has been used. Thank you.
Thank you. Any questions? So can you show the EPR spectrum of pure honey and adulterated honey? You showed one slide. So is there any difference between these? Can you elaborate on these two figures? One is pure and the other one is adulterated with 10% sugar syrup. So what are the difference? Is there any difference in the EPR spectrum between these two?
Seeing the EPR spectrum, we might not be able to recognize the much change, but we can get the parameters such as correlation time, first line width, third line width from the EPR spectrum. And on seeing these parameters, we can see that there is a gradual decrease.
Okay.
From that, we can identify the adulteration.
So what are the other methods? You mentioned already some of the methods. Nowadays, which is the most efficient method to check whether it is adulterated or not? You mentioned so many methods. My question is, which is the best method which we utilize now?
I do believe that we can make use of the EPR spectrum because for the industrial microfiltration methods and other chemical analysis methods do have their own drawbacks. However, if we make use of this method, it would be a
Is it a widespread method now, this CPR?
no, sir. It's
No.
not a widespread method because the instrumentation is
No.
not that easily available.
So now we use other methods.
Yes, such as industrial microfiltration.
Okay. Thank you, Ashna.
Moving on to the final presentation, Fatimatu Sahada will present Finding New Realms in Cancer Treatment, an approach based on anti-psychotic drug repurposing for anti-cancer activity.
Distinguished panels, distinguished prodigies on the dais, Indian faculties, and all the ones who have gathered over here. A very warm good evening to one and all. Sorry. My name is Fatima Sada, and I'm a second year MSc Chemistry student from Maranatha College, Kodamangalam itself. And the work, Finding New Realms in Cancer Treatment, an approach based on antipsychotic drug repurposing for anti-cancer activity. I've been doing this under the guidance of Dr. Rubel Marian Lenzi from IIIT Kottayam and from Dr. Anuvanna Varghese, my beloved teacher from my very own chemistry department itself. So, what is cancer? Actually, the name itself is so much threatening to us. It gives a destructive feel to us, right? Cancer is on its journey to slowly hover onto the human race, while we humans are not no one less than anyone. So definitely, we are arming ourselves with new technologies, and one among those technology in drug designing is drug repurposing. So, the objective of my work is to find if already approved antipsychotic drugs are able to help in anti-cancer treatment, thus we can bridge the gap for discovering a new drug for the same. As I've told, cancer is one of the most deadliest disease that human race has ever seen. What is cancer? It is a disease in which some of the body cells grow uncontrollably and spread to various other parts of the cells. It spread and invade the nearby tissues and causes metastasis by spreading into other organs, tissues, cells, and causing annihilating effect on the human body itself, which can eventually lead to death. 1 in every 6 deaths is caused due to cancer. According to the 2022 statistics, 10 million deaths are reported yearly just because of this cancer. The challenges of traditional drug research is that it is inherently laborious, arduous, time-consuming process, costly and a risky journey, and statistics says that over $2.8 billion are spent to just find a new drug, but the result that we get is not reliable enough because the result success rate is less than 10%. So there is a diagram showing the comparison between the traditional de novo drug discovery and the drug repurposing approach. From the diagram, we can see that 30% success rate can be obtained by drug repurposing study. Actually, drug repurposing is mending the gap between the drug discovery, new drug discovery. So, now moving on to the slide, what is drug drug development. It is a low-cost method. It is highly efficient and a minimum risk of failure is seen. Now, what is the role of AI in drug repurposing, which we can name as computer-aided drug design, which was invented early in 1980s. It is a facilitated drug screening. It can simulate the lead compounds, it can construct them and calculate the interactions between the ligands and the receptors. It's a very faster, softer, easier and less expensive method, and it helps to provide broad availability of both the disease-related and drug-related data. It also helps to provide unprecedented knowledge of biological mechanisms of drug and cancer and their modes of action. Okay, so the method I've used here is molecular docking. What is molecular docking? Docking is a prediction of the ligand conformation and orientation within a targeted binding site. And the aims of docking studies are to provide the accurate structure modeling and correct prediction of the activity. It is a multi-step process. It begins with using certain algorithms to bind the molecules, especially small molecules, to the active site. And complemented by scoring functions, we can predict the biological activity through evaluation of interaction between the compounds and the targets. The tools I've used here are being displayed in the slide. Now, a question which can be arised is that why I've chosen antipsychotic drugs itself. It is just because of the similarity in the mechanism that it is possessing with the anti-cancer drug, like multiple intracellular function including metabolism, cell stress, cell cycle regulation, survival and apoptosis through the modulation of sorry again. Beginning from what I've stopped, survival and apoptosis through the modulation of cellular signaling pathways, like PI3K, AKT, GSK, 3-beta pathway, etc. And they can counteract the growth of tumor cells by stimulating the cellular immune system. Killer cells. Anyway, the positive charge and the lipophilicity of antipsychotics again prove it as a very good option to dock against the anti-cancer proteins. Overall, antipsychotics can be used to inhibit the proliferation of cancer cells through the modulation of different cellular pathways. Now, the cancers I have chosen here are breast cancer and prostate cancer. We all know that breast cancer, prostate cancer has been listed under the 3 most deadliest cancers that the human race has witnessed. So, breast cancer is the second most common cancer found in women. Here the breasts grow out of control and different kinds of breast cancers are present, and various pathways are also present like HER2, ER pathways, PI3K, AKT pathways, etc. The very first pathway I have chosen here to dock with the proper protein is the PI3K pathway. Phosphatidylinositol 3 kinase, PI3K, which is abbreviated as PI3K. It is a crucial intracellular pathway which can signal breast, gastric, ovarian, colorectal, prostate and various other cancers. Here what happens is that a growth factor gets bind with the receptor molecule and it grows phosphorylase and it generates PI3K, which has the potential to go for a cell proliferation, which can ultimately lead to cancer. So ultimately what we have to do is that we have to inhibit the PI3K protein. Now, moving on to the results and discussion. The pathway, as I said, I have chosen PI3K pathway. The target protein is PI3K, subunit alpha isosome protein, and the ligand of interest is aripiprazole, which has a trade name Abilify. Aripiprazole is a schizophrenia drug. It is a second generation schizophrenia drug with less amount of side effects. On docking through autodock vena, the following result was able to produce. And the next figure, it provides the best confirmation the protein and the ligand has. And in the third figure, it provides the ligand protein binding results. And the fourth figure demonstrates the proper binding of ligand site in the protein. And these all figures corresponds to the very least energy confirmation as that of minus 8.5 kilocalorie per mole binding affinity. Okay. This slide portrays the ligand interactions that aripiprazole is making with the receptor protein, and the data table shown beneath provides the information regarding the interactions it makes, like hydrophobic, These are again some interactions that the ligand and the protein are making, like aromatic hydrogen bond, hydrophobicity, and solvent accessibility. Here to the hydrophobicity of the graph and the residue solvent accessibility gives us proper information regarding the binding of ligand and the protein docking site. This is the receptor ligand interaction in 2 dimensions. The kind of interactions the ligand is making with the amino acid residues nearby the pocket. And it can be interpreted based on the color it is given beneath the slide. Like green shows for the van der Waals interaction, pink shows for the pi T-shaped interactions, etc. This is a data table generated, which again gives information regarding the kind of interactions like hydrophobic, van der Waals, and halogen kind of atoms present in the site. Comparison of the results again. Tamoxifen is a conventionally used drug to treat the ERR3 gamma kind of protein cancer. Again, we were able to generate a very far better result, minus 9.8 kilocalorie per mole using trifluoperazine as the new drug on repurposing. The third cancer I've chosen is prostate cancer, and the pathway is RIPK2 pathway. The protein chosen is RIPK2 kinase domain protein, and olanzapine is the ligand I've chosen, which is a bipolar disorder drug. Again, in RIPK2 pathway, the inhibition of the RIPK2 protein is required to impair the metastatic outgrowth of the cancer cell. The results I've obtained is shown in the slide. At the very first confirmation, that is a minus 7.5 kilocalorie per mole of binding affinity is found to be the best confirmation of protein and the ligand. These are the interactions, and the graph on plotting hydrophobicity, pKa, residual accessibility, solvent accessibility against the amino acid residues is being shown here. And this is a 2-dimensional data of the same. Now the conclusions I can make from this is that during the corona, what we have seen is that due to the outbreak of such a disease, which has a potential to kill many of the human race, what we did the very first was to existing drugs, we repurposed it. For example, we used remdesivir, which is an antiviral drug, which has a potential to work against corona. That was the first drug that we could ever use. This is through drug repurposing. A very common example that I can say is that aspirin. Aspirin is taken as an antipyretic to reduce the body temperature. But the same aspirin is given to a patient who is having heart attack. So it has got multiple activities, and the same idea is being exploited in the case of drug repurposing. So through the 3 experiments I have done, I could reach up to the conclusion that computer-aided drug discovery is quite helpful in bridging the gap between the drug discovery and the treatment. And alpelisib, against alpelisib, aripiprazole was found to be a very good drug to treat the PI3K generated cancer. And from ER signaling pathways also, trifluoperazine was found to be a good drug against the conventionally used tamoxifen. These are the references I have used. And I would like to thank the entire chemistry department for supporting me throughout the work, and my guide, Dr. Rubel ma'am from IIIT Kottayam, for giving me proper guidance throughout the work, and definitely STAM for the opportunity to present my work over here. Thank you so much.
Very interesting talk. Now the session is open for questions. So what is the reason for this protein ligand binding? I understand there are many factors, hydrophobicity and all the pi stacking, there are many factors. But what do you think, which is the most important and the most influencing force?
I would say that hydrophobicity we can take for example for the instance, because more the interaction with water molecule it occurs, there is a chance for the ligand to break down. So thus disrupting its activity towards the proper displaying of its role. So as more hydrophobic the ligand is, more stabilizing it would be that protein and ligand complex, thus functioning that inhibition activity.
Okay.
So can you elaborate on how this medication can target specific cancer-related protein signaling pathways?
Pardon sir, can you please repeat the question once again?
Can you elaborate on how this medication can target specific cancer-related protein signaling pathways?
Actually, the work is not yet reached to that extent. This is just the beginning of the work. But I would say that the kind of interactions the ligand and the protein are making can definitely say serves a very good answer to what is said, sir. But I will definitely look into what you have said and come up with the answer. I think pharmacomodeling pathways would help to develop or find the mechanism of actually how the ligand and protein are binding. I'm not up to that. I'm working on the ND simulations only now. So pharmacomodeling would be conducted, and afterwards I will be able to answer your questions.
Okay, thank you.
Thank you all once again.
Good evening all. First of all, I would like to thank our evaluators, Dr. Jijo sir and Rajesh sir, for accepting our invitation and coming over and evaluating all these oral presentations. So on behalf of MA College Association and each and everyone who have gathered here, I thank you both. Also, I take this opportunity to thank all the presenters who have presented the offline session today, and I request if there are any offline presenters for tomorrow's schedule, please do hand over your PPT beforehand because by tomorrow we will be starting our session by 9 o'clock. So I request all students to be present here by 8:45 by tomorrow. Hope you all had a very good sessions of today. So see you all tomorrow. Thank you.